We are talking today with David Suzuki. He is co-author along with Wayne Grady of the book Tree, A Life Story. David, thank you for spending time with us today.
My pleasure.
Let me begin and ask you, what was the motivation in writing your book, Tree?
That's what everybody asks me. First of all, they say, wait a minute now, you're an animal guy. I was trained in zoology as a geneticist, and all my life, trees are kind of backdrops. They were there, but they aren't cute and cuddly. They don't move. They don't make sounds. And so one tends to take them for granted. In the last 10 or 15 years of my career as an environmentalist, one of the points I try to make is that we've come to think that we're somehow separate from the natural world, that we're so clever we create our own habitat and cities and we don't really need nature, that it's the economy that is the most important thing. And so I've been trying to reconnect us back into the real world by saying, if, like any other animal, if we don't have clean air, clean water, clean soil, clean energy that comes from the sun, we're toast. So trying to show that we're still dependent on the services that nature performs. And so I began to think about this idea about 10 years ago when I wanted to do a book for kids. And the idea was this kid's walking through a field and he sees a weed and just grabs it and absent-mindedly pulls it up and discovers that the whole world is connected to that weed. And it kind of evolved then into this tree on my property. It's about a 500-year-old Douglas fir, and it's got a funny shape. And as I thought about that tree, I began to realize, it's a miracle that a tree can actually survive. I mean, starting from the moment that a seed lands on the ground, it can't just pick up and say, this is a crummy piece of land, I want to go somewhere where there's more soil. They're stuck. And then from the moment that root sends its tip down into the soil, it's got to make its living in that spot. It's got to get all of its nutrients, its nitrogen, phosphorus, everything out of the soil. Of course, it takes carbon out of the air and carbon dioxide to make itself. And it can grow up to 300 feet above the ground and live for 1,000 years. I mean, you start thinking about it. I'm sure you've seen trees that seem to be growing out of solid rock, and you wonder, how the heck do they do that? So that tree, once it starts going, that's its place on this planet. And, the other thing is everything wants to eat that tree, insects and fungi and birds and mammals. And it can't slap off pests or go and hide. It's got to take whatever's coming at it. And you realize that it must have a whole bag of tricks in order to survive for 1,000 years. And it was just looking into the various bag of tricks that you begin to realize, my God, this really is a miracle. I mean, for one thing, a lot of people don't know that when an insect begins to drill into a tree, it immediately begins to produce a whole raft of chemicals that basically are insect repellents or poisons. And many of these compounds are very volatile. They evaporate in the air, and they drift through the forest. And if a tree nearby detects these chemicals, they go, oh my God, Jack is being attacked by insects. I better start pumping out my own chemicals. So, people say to me, are you telling me that trees communicate? Yes, they do. Through the air, they're actually sending information out to each other. And of course, there's a whole universe under the soil. We never wonder what's under the ground. This dark, mysterious world is where the roots grow. And if a tree's roots encounter another tree's roots, they don't go, oh, excuse me, and pull back. They actually twine about each other and may actually penetrate into the other tree's roots. And if one of the trees is down in the lower part where they get more water, and one of them is higher up where they get more sunlight, they'll actually begin to make deals, and the tree with the water will trade its water with the other tree for the sugars that are made in the leaves of the tree that gets more sunlight. So they're actually helping each other out. So tree is far more than just that one individual. It's a community of organisms that are working together for their mutual benefit.
Sounds like we could learn a lot from studying trees.
A lot, yeah. I think one of the most amazing stories is, French are big fans of truffles. I think in North America we don't think much of truffles, but the French love truffles, and they are the connoisseurs, and they cook them in all kinds of ways, and it's the height of gastronomy. And about 150 years ago, the King of Prussia said, listen, I want to carve out a place in the truffle market. So I want to find out how we can grow these in our own fields or in greenhouses. Now, the French, this is another story, but the French use female pigs to find truffles. And the reason they do that is the truffle makes a chemical that's very much like a male sex hormone. So they use the females because they think, oh, I might get lucky. And they start digging into the ground, and then the farmer can grab the truffle when they find the truffle. Well, what the King of Prussia wanted to do was to be able to grow them like carrots or tomato plants. And he assigned the job to a scientist who knew the truffle was the fruiting body of a fungus. So the first thing the scientist did was to begin to take away the soil and try to trace where was this fungus growing. Well, it turned out that it was a part of a huge mat of fibers going out. And when he tracked them down, they were wrapped around the roots of trees. And when you look at the roots, every little fine hair, and there are hundreds of kilometers of hairs growing out of a tree, all of those are surrounded by this lacy gauze of fungus. They're now called mycorrhizal fungi, and they're associated with trees. And a Douglas fir may have up to 1,000 different species of these fungi. Some of them are only found associated with the Douglas fir. And what they do is this. Even though the tree has this enormous network of roots, you still don't get enough surface area to come into contact with the soil. But when you get all the fine strands of the mycorrhizal fungi, they will amplify the surface area exposed to the soil hundreds of times. And so they absorb massive amounts of water and other nutrients in the soil. And they give the tree the nutrients and the water. In return, because they're fungi, they don't photosynthesize, they can't capture the sun's energy. In return for the sugars that are made in the leaves that are given back to the fungi. So you see this unbelievable association then of a totally different group of plants, fungi, that have a mutual benefit, that one serves the other and vice versa. And we didn't even know that 150 years ago. And now we know if you take a seed and plant it in soil, it's sterilized so there's no fungus there. The tree basically does very poorly and will die. They can't survive without the mycorrhizal fungi. And of course the fungi can't survive because they can't photosynthesize, so they depend on the tree. So there's this amazing association. Now the other story that's really interesting is scientists have always wondered, how the heck can we get such big trees, Douglas firs and hemlock and spruce and cedar in the temperate rainforest, because it rains a lot and washes nitrogen out of the soil. So nitrogen is a limiting growth factor in the soil, and yet you get these giant trees. Well, the answer is fish. The salmon go to sea by the tens and tens of millions. And out in the ocean, they start growing and accumulating nitrogen from the ocean. And it turns out the nitrogen in the ocean is different from the nitrogen in the land. So it's the marine nitrogen is rich in an isotope called N15. It's heavier than the isotope found on land, which is N14. So you can follow the marine nitrogen that is brought back by the salmon, because the salmon are full of nitrogen 15. So the salmon come back mature, and immediately, of course, the wolves and the eagles and the bears are eating salmon, and they go running through the woods and poop in the woods, and they're fertilizing the trees. So there have been scientists like Tom Reimken at the University of Victoria that has drilled holes in the trees to get cores, and he can show when you've got a nice fat ring, you measure the amount of nitrogen 15, there's lots in there. When it's a skinny ring, you don't have as much nitrogen 15. So you literally are growing the forest off the meat of the salmon that are coming back to feed them. And the interesting thing is that if you've ever gone in a forest when the salmon are running, it's quite shocking. You find salmon carcasses 400 feet away from the riverbank, often up the hills, and you wonder, how the hell did the salmon get here? They're not jumping up and flopping around that far away. Well, it turns out it's the bears. The bears will hunt for the fish together with other bears, but they're solitary animals. They don't like to eat them with the other bears. So the minute they grab a salmon, they take off into the forest. And they'll eat the best parts, which is the brains and the belly. and then they'll leave the carcass there. And of course, the carcass is immediately eaten by salamanders and slugs and beetles and ravens, and everything's eating the carcass. But about half of the carcass is eaten by maggots of flies. The flies lay eggs, and a few days later it's just a seething mass of maggots which consume all the meat. Then the fly larvae drop into the forest. And the next spring, the flies hatch by the billions, just at the time that the birds from South America are coming through on their way to the Arctic. So the salmon go to the ocean, they load up on nitrogen-15 from the ocean, they come back, they feed the animals, they feed the plants, they feed the trees, and they feed the birds that are coming through. So it's all a part of a single system. Now the bottom line is this: humans come along, at least modern humans, and we say, oh, well, we've got all these resources. Let's let the Minister of Indian Affairs deal with the native food fishery, and the Minister of Fisheries and Oceans deals with the commercial fishers, and the Minister of Tourism, he deals with the sports fishermen. And then, of course, we've got the rivers. Well, that's the Minister of Agriculture for irrigation and the Minister of Energy for hydroelectric power. Then the forest, well, that's the Department of Forestry. Then the eagles, the bears, the wolves, that's the Department of the Environment. And the mountains and the rocks, that's the Department of Mining. And what we do is we take a single system of ocean, forest, and southern hemisphere, and we break it up into pieces for our reasons, and we make absolutely sure we will never manage our resources in any way that is sustainable, because we break it into pieces and we never see the connections. So really, that's why I wrote the book. Focusing on that single tree, you find that it connects us to the whole world. And that's what we've got to learn, is that we're a part of that world too. That tree is breathing oxygen out that we depend on. That tree's roots are taking huge amounts of water, breathing it out into the air and affecting weather and climate that affect us. That tree offers habitat to eagles and wolves and all kinds of creatures that live in the forest that we value as well. So through the life of a single tree, I hope that we realize that it embeds us all together into a single world.
One of the big factors here with Douglas fir is, of course, our forestry practices.
Yes.
Do you see it possible to, with our current economic models, to be able to work a sustainable forestry practice?
Absolutely. It is possible. It's not as easy, but I like to cite two examples in this part of the world. One is the native community, and I can't remember which tribe they were, that has a huge part of the Washington state. And they manage that forest, including logging, but their primary concern is ensuring the traditional use of that forest. So sure, they cut trees down for economic benefit, but they also want their berries that they pick every spring. They also want their traditional areas. They want their salmon protected. They want their traditional sacred areas protected. And by managing it in a holistic way, I think it's the Yakima Indians that are managing that forest sustainably. And then I look to Collins Pine, which is a family-owned company that's been logging for 150 years. They own large tracts in California and Pennsylvania and in Oregon, and their forests are considered among the richest forests in the Pacific Northwest, and they've been logging it for 150 years. They never clear-cut log. They do $250 million worth of business a year, so it's not a mom-and-pop operation, and yet they've been able to sustain the forest and make a living for the company and for thousands of employees and for the communities around Collins Pine, which they support a great deal. So if you want to maximize profit for your shareholder, you don't do it the way that Collins Pine is doing it. But Collins Pine has been in the business for 150 years, and they'll be here forever if they carry it out the same way. But these companies that are clear-cut logging and maximizing the return for their shareholder, they're not going to be around very long because they're not looking to 150 years from now.
Well, and if you look at who the true shareholders are, the people and the animals and the other, creatures on the planet.
But they don't come into the equation is the problem. You're absolutely right. The shareholders we have are human shareholders with money who want to maximize return on that money. But all of the other beneficiaries of that forest, who derive the services performed by that community of trees, those don't factor into the equation. And that's the terrible part. You know, I took a course in economics a few years ago because I realized that as an environmentalist, I had to take economics very, very seriously. And the minute the economist shows a picture of the economy, you know, raw materials, extraction, processing, manufacture, wholesale, retail, all this stuff, you get this very complex picture of what is considered the economy. If you ask, as I did, if you ask a professor or an economist, in that equation, where do you put the ozone layer? Where do you put the deep underground aquifers of fossil water? Where do you put topsoil or biodiversity? You know what they say? The answer is, oh, those are externalities. Now, I'd never heard the word externality used this way before. It's apparently an economic term that means they are outside of the economy. Excuse me, what are you saying? The economy doesn't take into account ozone layer, fossil water, topsoil, biodiversity? Then what the heck is the economy based on? All of those things are crucial to keep the natural world going, and surely everything we extract from the world to use in our economy comes from the biosphere, comes from the zone of air, water, and land where life exists. But economists consider these, most of that, externalities. And that's the problem. The rot at the heart of our conventional economy is that we consider those things so abundant, they don't even have to be factored in. And it's based on the notion that humans are the most productive, inventive part of the economy. There'll never be a limit to human productivity or inventiveness. Therefore, economists think the economy can grow forever. Well, if we live within a finite zone of the biosphere, it's fixed. It can't grow anymore. How can you have a system within that trying to grow forever? That's like the cancer cell that exists within our bodies thinking it can keep growing forever. Well, the end result is death. And it will be the same thing if we allow this economic juggernaut to continue to grow as if it can grow forever. But that's the rot that underlies conventional economics. It's based on human productivity and inventiveness, and we think there are no limits to that, so the economy can grow forever, which it can't.
So how do we deal with the rot?
Well, there are people called ecological economists that are trying to internalize what traditional economics externalizes. So I have to admit that I'm very, very nervous about ecological economists. These are good guys. Many of them I know, and they mean well. But I happen to think there are a lot of things in the world that are sacred. They're beyond putting a price on. I get worried when economists try to say, well, what do we think the economic value of the air is, or the water, or other species? You know, let's try to put a dollar and cents value on that. That worries me a lot, because I think sacred things are just priceless. But I think as an exercise, it's very good to say, okay, what are all the things that nature does for us that we now consider an externality? What would it cost us to do what nature is now doing for nothing? For example, Vancouver gets all of its water from 3 watersheds surrounded by old-growth rainforest. Now, the foresters keep saying, you know, those trees are worth a lot of money. One tree is worth over $40,000. We should cut them down and plant more trees. And lots of us are saying, wait a minute now, you can't ever duplicate that forest. It's filtering the water for us. But if the foresters went out, maybe we could build a huge filtration plant and filter the water and clear-cut that watershed. Well, we could ask, how much would it cost then for us to build that plant? That gives you a dollar and cents value of what that forest is doing right now for nothing, okay? We could ask, lots of things die in the forest, animals, plants, and yeast and fungi and bacteria decay that material and return it back as compost. What would it cost us if we had to go through and compost everything ourselves? What would it cost us to try to pollinate all of the flowering plants that insects now pollinate? So you get the idea. This is what nature does. Could we build a plant that would remove carbon dioxide and put oxygen back in the air and all that? So Bob Constanza and his group at the University of Vermont tried to put a dollar and cents value on nature's services and came up with a value of $33 trillion. Now, to put this in perspective, at the time that they published their paper, the annual economies of all of the countries in the world came to $18 trillion. So all of the economies of the world were producing almost half of what nature is doing for nothing. And that nature services are considered an externality. So that's kind of nuts. So I think as an exercise, it tells you we better take nature pretty damn seriously, because otherwise it's going to break the bank for us to try to duplicate what nature is doing for us for nothing.
Let me ask you, you have been covering environmental and science issues for years. What is your sense of where we are in the big scope of things?
Well, I keep saying that I feel as if we're in a giant car heading at a brick wall at 100 miles an hour, and everybody in the car is arguing about where they want to sit. It doesn't matter who's driving. Somebody's got to say, turn the wheel and put the brakes on. But there are a few of us saying that, but we're locked in the trunk, so nobody hears us. So the reality is, from my standpoint, we're heading right at that brick wall flat out. We're going the wrong direction, and we're going way too fast. And it's not David Suzuki or Greenpeace or Sierra Club that are saying this. The leading scientists of the world are telling us. They've been saying it now for decades. Let me show you what the reality is. The World Wildlife Fund UK did a study last year in which they took 6 different categories of renewable resources: trees, fish, and we should be able to harvest these sustainably forever. And they said, what is the total human consumption of these 6 resources? And how long does it take nature to return or replenish what we take out in a year? Okay, so if it takes a year or less to replenish what we take out in a year, that's sustainable. We should be able to do that forever. What they found is it now takes 1.25 years to replace what we take out in a year. That's deficit financing. And this deficit has been going on since the early 1980s. So we're living in a fool's paradise then. What this says to us is that we're not living sustainably, and we're using up what is the rightful legacy of our children and grandchildren. And we think it's a waste if we don't keep using this stuff up. But that's the reality, the hard data. Fish biologists told us last year that 90% of the large fish in the sea are gone, and they haven't come back, and nothing has come back to replace them. So, bluefin tuna, swordfish, sharks, northern cod, orange roughy, Chilean sea bass. We've been mining these fish. We've not been harvesting them in a sustainable way. We've added 32% more carbon dioxide to the atmosphere than existed 150 years ago because of all the fossil fuels. And yet the largest polluter of fossil fuels, user of fossil fuels and polluter, is the United States. With a population 5% of the planet's population, you're producing 25% of the greenhouse gases of the world. And yet you have a president that says there's no way I'm going to pay attention to what scientists are telling me. We can't do anything to jeopardize the economy. So if the richest country in the world is not willing to do anything about it, even though the leading scientists of the country are telling us climate change is real and we've got to do something, then we're going straight at that brick wall at 100 miles an hour. The United Kingdom, with Tony Blair, and the last time I heard they were industrialized, they are committed to a 60% reduction in greenhouse gas emission by the year 2050. And the European community is committed to going way beyond the Kyoto Protocol. Russia has now ratified the Kyoto Protocol. In January, it will become international law. The question is the United States and are the United States and Australia going to continue to remain eco-bandits around the world and say, to hell with you, we're not going to jeopardize our economy? That's the big question that the rest of the world is now waiting to hear answered.
So it really falls on U.S. citizens to take charge.
Well, the United States is the most powerful country in the world. You are the major predator in terms of the use of global resources. The United States seems to feel, as does Canada, because we copy what you do, that more stuff is the key to our happiness and well-being. We have an economy that is just roaring ahead, using stuff. Over half of our automobile fleet now in North America are sports utility vehicles, which are a major contributor to the depletion of of the world's energy resources, and nobody's asking how much is enough. Do we need all this stuff? Are we happier? Last time I heard, you've got huge problems in this country with the largest per capita number of people in prison. You're imprisoning people because they're smoking pot, and they're problems that are not major crimes, but you've got a problem of dysfunctional societies. 44 million Americans have no access to medical care. I mean, it seems to me all this wealth, what good is it doing if you have large numbers of people who are disaffected, who are alienated, who are not able to get the basic needs in life? The measure of your society is not by the number of billionaires you have. It seems to me the measure of your society is in the state of your poorest, most vulnerable people. And by that criterion, the richest country in the world has got a hell of a lot of problems. And I think it's really time that we sat down and assessed not only what the priorities really should be in this country, but your place in the community of countries around the world. After 9/11, I have never seen such an outpouring of love and unity of countries around the world with the United States. 2 days after 9/11, 100,000 Canadians gathered in front of the American Embassy in Ottawa to say that attack was an attack on us. That as Canadians, we are brothers and sisters of the United States. And millions of dollars poured out of the pockets of ordinary Canadians to support the people in the United States and New York. And yet when Mr. Bush made his statement in Congress to thank the countries in the world, Canada was left off. Canada is the largest trading partner of the United States. The largest source of oil outside of the United States is not Saudi Arabia, it's Canada. And Canada showed how much we care about Americans, and yet we were not even mentioned. I can't tell you how painful that was to me as a Canadian, especially because I lived in the States for 8 years, and I feel an eternal debt to the United States for giving me an education I couldn't possibly get in Canada. And then I supported Mr. Chrétien, our Prime Minister, when he said, no, we will not go into Iraq without the backing of the United Nations. And at that point, Mr. Bush beat up Canada terribly and just said, don't you ever dare try to come and get American support in going into Iraq to help the reconstruction or anything. You know, you didn't support us, you're against us. And again, that really hurt everybody, because we are your closest neighbor, we're your closest trading partner, and we feel a tremendous affinity. Dozens and dozens of Canadians died in the Twin Towers when that happened, and to be written off because we didn't toe the line was a very, very hurtful thing. And I think Mr. Bush has squandered a huge amount of that global concern and brotherhood and sisterhood.
All right. Well, I want to thank you for spending time with us today.
Thanks for having me.
We have just been talking with David Suzuki. He is author, along with Wayne Grady, of the book Tree, A Life Story.